This is Algebra 2 with Trig, Unit 1C.4b. It's our second day talking about completing the square. Today we're going to talk about how to take standard form and switch it over to vertex form. So we know that vertex form, that we've learned before about a quadratic equation, has the h and the k. So notice that this has a perfect square inside. We're squaring a binomial, and we can reach that by completing the square of a trinomial. Now our organization for solving using completing the squares was a little bit different than this organization. You can subtract the 22 to the other side of the equal sign. That would just work fine. But I want to show you that you can also just push that 22 off to the side a little bit, making room for turning this into a perfect square trinomial. So like we learned for completing the square, we take our b term divided by 2 and square it. So our b term is negative 10 divided by 2 and square it. That's negative 5 squared, which is 25. So the 25 is an important value. I'm going to rewrite this just so we all notice that there's a step to move the 22 to the side, and then there's a step to write the 25 inside of the parentheses. Now I wrote a 25 inside here. We would have to also add it to the other side of the equal sign to keep it balanced, but that's not where this, oops, sorry, that's not a 25. Isn't that 22? So since I didn't subtract the 25 to the other side, I don't have other numbers over here. So I don't have to keep it balanced on that side. I have to keep it balanced all on the same side. So if I add 25 to the right side, what else do I have to do to the right side to keep it balanced? You would have to subtract the 25. So why did we put the 25 here? So that we could recognize what the squaring of a binomial would be for this perfect square trinomial. I created a perfect square trinomial so that I could write it as a binomial squared. This becomes negative 3. So my vertex, notice that our vertex, which they're asking for up here, identify the vertex. The x value is always the opposite of what's inside your parentheses, as it's been all year. Because our equation here was x minus h. X minus h, we have x minus 5, so h was a positive number. So that's why for our x, the vertex is a positive number. Let's try it again on this side. So I push my 95 off to the side. You can switch it over to the left side if you like. If that makes you more comfortable, that's just fine. We're going to take our b term divided by 2 and square it. That's our 18 divided by 2 and square it. That's 81.
Wait, so it's 81x, right? Or just
So our 81 I have the 95 off to the side. The reason why 91 was important was so we could write this binomial squared, which is always going to be the value in your calculation. That's divided by 2, gives you 9. So whatever you're squaring is what goes inside here. So because I put the 81 here, I also have to put a negative 81. Because I added 81 to the right side of the equal sign, I would have to subtract 81 to the right-hand side of the equal sign to keep it balanced. So that looks like it's up by 14. So my vertex is negative 9, negative 14. Negative 9, positive 14. Okay, we're going to scroll down here. We know that this is a little bit different because the coefficient is not 1. So we do have some options. I'm going to push my 7 off to the side. As we did on the last lesson, I'm going to factor out that leading coefficient from the A and the B term. So I'm leaving a quadratic left over that has an A value of 1. Now I take my B term divided by 2 and square it, which is 1. So we need 1 to be in the parentheses. If I put 1 inside the parentheses, what value do I have to subtract from this side?
5.
Because a 1 is actually going to put a weight of 5 because of the multiplication to distribute. So making a 1 in here is really making this a 5. So I have to subtract the 5 to keep it balanced. And this is x plus 1 squared plus 2. So my vertex is negative 1, comma 2. So now we're going to look at some word problems. Here's a formula for throwing an object, not just dropping an object. So a ball was thrown up in the air from the roof of a building after t seconds. This is our height. So what is the maximum height? So really, we're looking for the vertex. We're looking for the y value that gives a maximum height. There's a couple different ways we could do this. We could plug this into our calculator if that was available to us. We could do negative b over 2a, find the line of symmetry and plug that in. That would completely work. We could complete the square if the numbers are nice enough. Let's find out if our numbers are nice. This is a completing the square section. So let's see if we can make that work. So y equals negative 16t squared plus 64t plus 50. I'm going to move this plus 50 off to the side. Now I know that my leading coefficient has to be a 1. So I'm going to factor out my negative 16. That leaves me a t squared with a coefficient of 1. By factoring out the negative 16, to get 64, I'm going to need a negative 4 in there because two negatives make a positive. 16 times 4 is 64. So now we're going to take our b divided by 2 and square it. That's negative 4 divided by 2 and square it. That gives us a negative 2 squared, which is 4. That's t squared minus 4t plus 4. Now notice what's going to happen here. By putting a 4 in here, that's really giving us a negative 64. Because it's 16 times that amount. That negative 16 times that amount. That's a negative 64. So I have to add 64 to the right-hand side. And that should be our vertex. So our height, all right, sorry, this is not 5, this is actually 50.
Why don't you subtract 64?
So that's 111, 114. That seems better. So our maximum height is y equals 114. I did my math here to get 114, but when I put the 0 back on here, this needed to have a number change to 114. Now we're all better. 50 plus 64, it's not plus 5, it's plus 50. That gives us our 114. Okay, last question. See if we can make this one work out. Here we're talking about the area of a triangle. We know the area of a triangle is half of base times height. Our base is 110, or x plus 10, and our height is 2x. So our area is 144 equals half of 2x times x plus 10. That's base times height. That's probably height times base, but that's okay. I can take half of my base, that's my height actually, but I can take half of it. I can distribute my x through to make x squared plus 10x, and we'll leave it at that. Since I already have the 144 on the other side, let's just complete the square from here. Let's take our 10 divided by 2 and square it. So that's 25. And since I'm on the opposite sides of the equal sign, I have to do the opposite of a positive 25. That would be a negative 25. That gives me 119. So this is going to become x plus 5 squared equals 119. Take the square root of both sides. And that gives me x plus 5 equals plus or minus the square root of 119. Subtract my 5 across. We want to be sure that we have the value that is a positive for your x. So that's going to be negative 5 plus the square root of 119. Not the minus. The minus would give you a negative. Minus 5 minus more is going to give you a negative answer. So here, that must be your x values, what I see. All right, here I just noticed my mistake. I did the opposites here. That was a little crazy of me. Sorry about that. Did you notice that? I often say, don't just be a copier. I added the 25 to the right-hand side of the equal sign. I have to add 25 to the left-hand side of the equal sign. That's 169. That's a lot better. So when we take the square root of both sides, I get plus or minus 13. So I get negative 5 plus 13, which gives us 8. That is much better. So my dimensions are going to be 2 times 8. So the height is going to be 16, and my base is going to be 8 plus 10, which is 18.